Okay, we're going to learn how to determine the measure of an angle in a right-angled triangle using trig. So we've used trig to find a missing side in a triangle. If we know that it's a right triangle and we know one of the angles and one of the sides, now we need to know that it's 90 degrees and two sides. Okay, so just like always, you want to label your triangle with reference, in this case, to angle A. So that means the hypotenuse, remember, is opposite the 90 degrees. Touching angle A is the adjacent with the hypotenuse, and opposite angle A is the opposite side. So that helps us with our trig ratios. Okay, sine, cos, and tan. So you can also remember that short form if that helps you. You'll have a formula sheet. It's also in the back page of your workbook. So it says, given the following triangle, determine each of the ratios as a decimal rounded to the nearest hundredth. So this is kind of review. We did this the other day. All right, so taking a look at, first we're going to look at angle A. So this is the hypotenuse, this is adjacent, and this is opposite. So sine of A is opposite over hypotenuse. We'll get our calculator out and find the decimal form in a second. Cosine of A is adjacent over hypotenuse, but we don't know what the adjacent is. So I'm going to call that x, and then let's calculate it. It's a leg, so we need to take the hypotenuse and square it and subtract the other side squared. So 144 minus 25 is 39, 119. So x is the root of 119. Okay, so cosine will be root of 119 over 12. And tan is opposite over adjacent. Okay, so if you get out your calculator, we can do these. So nearest hundredth. So 5 divided by 12 is 0.42. We're rounding. Then square root of 119 divide by 12 is 0.91. And then 5 divided by square root of 119 is 0.46. Okay. Next, if we go, I'm going to switch to red, so our angle B. So now 5 is adjacent and x is opposite. Hypotenuse stays the same. So for finding sine of B, that's opposite over hypotenuse. So that's root 119 over 12. The same as cosine of A. Cosine of B is adjacent over hypotenuse, so those are the same, and tan is opposite over adjacent. So this is the same as cosine of A, so we know that's 0.91. This is the same as sine of A, so that's 0.42. And then just need our calculator for the last one. Square root of 119 divided by 5, 2.18. So it says use any of the ratios above to determine the measures of angles A and B. Well, how do we do that? So we have here, so let's take sine of A. So sine of A is 5 over 12. So what we do in our calculator to get A by itself is we have to do what's called inverse sine. So inverse looks like a -1 in the exponent. It's not an exponent. It means sine inverse of 5 divided by 12. So in your calculator, you're going to look for pressing the second key or the shift key on some calculators. So you would go shift or second sine. So on my calculator, I see the -1. Then you enter 5 divided by 12. So it's basically you're telling the calculator what the ratio is. It's going to give you back the angle, 24.6. Doesn't say what to round to, but that's what I'll round to 1 decimal place. Okay, now B, you could just go 180 minus 90 minus 24.6. You don't actually have to use a trig ratio. That's really 90, so 90 minus 24.6 is 65.4. Okay, so that's the biggest thing. So some calculators, if you don't see the word sine on your calculator when you press that button, then you need to put 5 divided by 12 first, then your second key, then your sine key. Okay, so it depends on your calculator. Okay, so here we're calculating the measure of angle A. So I'm going to circle angle A. Then what sides do I know? Okay, just deal with the sides that are given to you. You have to have a 90-degree triangle and 2 sides in order to calculate an angle. So this is the hypotenuse and this is the opposite. So we're going to use sine here. So sine of A equals opposite over hypotenuse. So then in your calculator, to get A by itself, it's going to be second key or shift key, sine of 12 divided by 50. So in my calculator, if you have a graphing calculator, it's second key sine. Okay, so anytime you're finding an angle, you have to press the shift or second key, no matter what calculator you have. And then 12 divided by 50. Okay, so that's 53.1. Again, it didn't say what to round to, so we'll go to 1 decimal place. Okay, so that's 53.1. If you had to find this angle, it would be 90 minus that. Here, angle A, what do we have? 8 is adjacent, and this is the hypotenuse. So we're going to use cosine for this one. So cos of A is adjacent over hypotenuse. Don't reduce it. Same thing here. You don't need to reduce it because this isn't your final answer. Your angle is. So now this is going to be cos inverse of 8 divided by 20. So second cos 8 divided by 20 is 66.4 degrees. Okay. Next one, here's angle A. Then this is opposite and this is adjacent. Okay, so that's tan. So tan of A is opposite over adjacent. So the angle will be the second tan of 8 over 17. And so that's going to be second tan 8 over 17, 25.2. All right. Okay, so some words or definitions that you need to know. The angle of elevation or inclination. That's from the horizontal looking upwards. What's the angle that's formed? Really, in this case, it probably should be from the eyesight here, so that horizontal up. But elevation is from the horizontal up. Depression is from the horizontal down. Okay, so think of being depressed, you're kind of feeling down, so it's looking downwards. Elevation, feeling up, you're looking upwards. Okay. So, some examples here. To be safe, a ladder should have an angle of inclination of about 75 degrees. A 14-foot ladder is placed against a vertical wall such that the foot is 3 feet. Is the ladder in a safe position? So I'm going to, oh, that's not what I wanted to do. Just a sec. Rectangle. So here's the wall. There's the ground. There's a ladder. Okay, and so it says, I've got to label some of these things. Angle of inclination, that's going to be 75 degrees there. It's from the horizontal upwards. 14-foot ladder, so that's the hypotenuse. It's a vertical wall, so it's at 90 degrees. 3 feet from the wall. Oh, actually, I guess step back here. To be safe, it has to be 75. So we want to check out what angle this is. Okay, if it's a 14-foot ladder, 3 feet from the wall. So this is adjacent, and this is hypotenuse. So cosine of theta is adjacent over hypotenuse. So theta equals cos inverse 3 over 14. So second cos 3 over 14, 77.6. And should have an angle of inclination of about that. So this is a little bit high. Okay, so that means it's a little bit steeper. The steeper it is, the more unstable, like whether you're going to be tipping backwards or not. So it's pretty close to being safe, but a little steep. Okay, next one, determine the measure of the angles between the diagonals of a rectangle and its sides if the width of the rectangle is 3.4 and the length is 8.1. So we want to draw those diagonals. So diagonal goes from corner to corner. And so we don't need to draw both of them because we want to know the angle between the diagonal and its sides. Okay, well, if it's a rectangle, these are all 90 degrees, right? So we just need to find this, and then we can subtract from 90 to find this one. I'll call it beta. Alpha, beta, and theta are common letters to use for angles. They're Greek symbols. So here, this would be 3.4 as well, because it's a rectangle. So that would be, compared to theta, that's opposite, and this is adjacent. So we would use tan. So tan of theta is 3.4 over 8.1. So theta equals tan inverse 3.4 over 8.1. Important to check on your calculator if you've cleared it. If it's a graphing calculator, you need to make sure that it's in, I'll show you degree mode, right? So here, make sure if you have a graphing calculator, it's in degree mode. Same with a scientific, but most times it's in a scientific, it stays in degree mode. You'll see a little D or a little DEG on your screen. Okay, so that's 22.8. Okay, and degrees, and therefore beta will be 90 minus 22.8 degrees. So 90 minus that answer is 67.2. Okay. And then on one part of the bicycle pathway along 14th Street in the Northwest, a cyclist travels a distance of 1 kilometer along the pathway while gaining 80 meters in elevation. Determine the angle of inclination to the nearest tenth of a degree. So basically, the pathway is kind of got a little bit of an incline in it. Okay, and we've got compared to the horizontal. So it says here that goes 1 kilometer and 80 meters of elevation. Okay, so this is 80 meters. This is 1 kilometer. And we need to determine the angle of inclination. Okay, that's that angle in there based on the horizontal. So notice here, you just have to be careful. These aren't in the same units. So 1 kilometer, I'm going to convert it to meters, is 1,000 meters. So now we want to calculate theta. So this is opposite, it's a 90 degree, and this is hypotenuse. So this would be sine. So sine of theta is 80 over 1,000. Theta is sine inverse 80 over 1,000. And so second sine 80 divided by 1,000 is 4.6. Oh, 100th of a degree, sorry, 4.59. Okay, and then now it's time to do practice from your workbook. The lesson's done.